Hello everyone, today we're going to look at measures of center. The average of a data set refers to any measure of center of the data. So when you ask for the average of the class, there are several different answers I could give you. The two that we see the most are the mean and the median. So we're going to talk about these two and a third one in this section. The mean is x bar if we're talking about the mean of a sample, and it is the sum of the x's over n. So remember, this symbol here is sigma, capital sigma, and it means the sum of. So I'm going to add up my values, divide by n. Again, this is what people typically mean when they say the average. They mean the mean. If I'm talking about the mean of a population, it's the same formula, but instead of x bar, we denote it by the Greek letter mu. So it's pronounced mu, but it's spelt mu. Okay, so it's a Greek letter M for mu. The median you've seen before in the measures of location. So sometimes it's called Q2, sometimes it's called M, sometimes it's called X tilde, and it is just the middle value. So we've actually already seen the median. So for an example, let's find the mean and median of the following data sets. And for now, we're going to use the notation that it comes from a sample. So we're going to use X bar. So here are the following data sets. If I want to find the mean, I need to add up all these values and divide by how many values we have. So n is 13, we have 13 values. And if I add up all those numbers, I should get 52. So that x bar is 52 over 13, which simplifies down to 4. Since n is odd, there is a middle number. So again, as we talked about in the measure of location, the median for an odd number of values is located at the n plus 1 over 2th spot if we order them in either increasing or decreasing order. So when I put them in order, you get 0, 1, 2, 2, 3, 3, 4, 4, 4, 6, 7, 8, 8. The middle value is 4. So there are 13 values. That means the 7th spot is the middle value. So if we count over, 1, 2, 3, 4, 5, 6, 7 is the first 4. So the median is 4, which happens to be the same as the mean. What if we have our numbers in a frequency table instead? I count up my frequencies. The total is 12, so there are 12 values. X bar is, we have 3 number 2's, so that's here. We have 2 number 3's, 3 times 2. We have 1 4, and we have 6 5's. So if I'm going to add them all up, I can just do that by multiplication. Instead of adding 2 3 times, I just multiply 2 times 3. Instead of adding 5 6 times, I'll just multiply 5 by 6. So I get that for my mean, and that will give me 3.83 repeating. That bar should really be extending over the entire 83. So it's 3.838383 forever and ever and ever. Since n is even, the median is the mean, or the midpoint, since there are only 2 numbers, of the 2 middle numbers. And again, those occur at the n over 2th spot and the n over 2 plus 1th spots. So in order to do that with a frequency table, we count 12. So that is the 6th and 7th spots. So here I have 3 2's. I have 2 3's, so that becomes numbers 4 and 5. Number 6 is 4. Number 7, the 7th number, would be one of the 6 5's. So in order to find the median, I'm going to take the average of 4 and 5. And again, I'm just counting. I've got 3 here, I've got 3 here, another 2, that's 5, plus 1 is 6, and then again, one of those 6 5's is my 7th. So the median, however you want to label it, is again the mean or the midpoint of 4 and 5, my 6th and 7th values, which gives me 4.5. What happens if we add an outlier to the previous example? So remember, an outlier is a number that's either a lot smaller or a lot bigger than the others. So I'm going to add in a number 40 into my data set. So to find x bar, I'm going to add up all the numbers. Again, I had the 3 2s, the 2 3s, the 1 4, the 6 5s, and then I also have the 140. This makes my mean jump up to 6.6. Remember, it was 3.83 repeating before. The median is now 5 because we have 13 values. There is a middle value, and that is the 7th value. And just like before, 3, 5, 6, so the 7th value is in here, which is the number 5. So the median went from 4.5 to 5. The mean went from 3.838383 to 6.6. So the x bar almost doubled, and the median only increased by 0.5. And this is an example of why the median is sometimes a better measure of center or a better average than the mean. If you have outliers, it's not going to affect the median as much as it does the mean. Which is why whenever we're measuring something that has a lot of outliers, like say job salaries or prices of homes, you're typically given the median versus the mean. If I have a bunch of homes that are around, say, $300,000, and there happens to be a $600,000 mansion lying around the area, that would bring the mean up a lot, but it doesn't do as much with the median. So when there are outliers, we typically look at the median versus the mean. And then our third measure of average is called the mode. So the mode is or are the most frequent value or values. The mode is the only measure of center where you can have more than one value. There's only ever one mean. There's only ever one median. There can be multiple modes. So we're going to find the mode of the following data sets. So here's our first data set. In order to find the mode, it's easiest and most helpful to order our values just like we do with the median. So I put them here in increasing order. So all my 2's are together, all my 3's are together, all my 5's are together. And I think it's fairly easy to see that I have more 5's than any other value. So the mode is 5. So here we look at another example. I've already put it in order for us. And if I look here, I've got 2 3's, 3 4's, 2 5's, a 6, 2 7's, and 3 8's. So the number that I have the most is actually 2 numbers. I have 3 4's and I have 3 8's. So the mode is both 4 and 8, and this data set is called bimodal because there are 2 modes. The first data set is unimodal because there's only one mode. But the second one, data set B, is called bimodal because, again, there are 2 modes. You can have multimodal if there are 3 or 4 or 5 modes. You can have as many modes as you want, really, but you just have to make sure that that is the highest frequency and they are the same frequency. So if I added in, for instance, for B, if I added another 8, this would no longer be bimodal because there are 4 8's and at most 3 of anything else. So whenever you're talking about bimodal or multimodal, the highest frequency has to be the same frequency for each number. So even if I have 1 of all numbers, 8 of another number, and 9 of a third of another number, even though 8 and 9 are both a lot more than the other values, there's only 1 with 9, so that would still be unimodal. Okay, so look over the section of the book. Let me know if you have any questions, and good luck.